This physics review video is from Unit 5, Projectile Motion. The topic is freefall. Freefall is when an object is experiencing one and only one force, the force of gravity. A force diagram for an object that's in freefall would look like this. There's one force, and it's in the downward direction. The reason that the force of gravity is in the downward direction is it points towards the object that's pulling on it, which is the Earth. Here's an example problem where a sphere is 45 meters off the ground, and we're going to drop it from rest. When we drop it from rest, that means that the initial velocity is 0 meters per second. And because this is a freefall problem, we also know that the acceleration is negative 9.8 meters per second squared. 45 meters is the height. However, in variable form, we need to know its final position and its initial position. Its final position is 0 meters. It's 0 because when it hits the ground, it will be at 0 on our scale. And at time equals 0, at the very beginning of the problem, the initial position is 45 meters. So there are some extra variables that we know. So what we can do is we can now solve for how long is the sphere in flight for, or in the air. So we're going to write down our givens. The initial velocity is 0 meters per second. Our initial acceleration, or really our acceleration throughout the whole problem, because the acceleration is constant, is negative 9.8 meters per second squared. I know that my initial position is 45 meters, and I know that my final position is 0 meters. So now I've got all my givens written out. I now have to find an equation, or pick my equation, to solve for time. Looking through my three equations that I use often, I notice that I don't have the final velocity, so I'm going to choose the one that does not have the final velocity in it. X equals 1/2 at squared plus v naught t plus x naught. One thing I know right away is, because v naught is 0, this whole middle term is going to be also 0. So I'm going to plug in everything else that I know. 0 meters equals 1/2 times negative 9.8 meters per second squared times t squared plus 45 meters. So I've got to see, what do I have to do next to get t squared by itself? That's my goal. I'm first going to bring 45 meters over to the other side. So I get negative 45 meters equals 1/2 times negative 9.8. I could do that. I get negative 4.9 meters per second squared. That's just a combination of these two terms right here. And I still have t squared. My next step is going to divide both sides by negative 4.9. When I do that, I get 9.09 equals t squared. Now that's not the value I'm looking for. I'm looking for the time, or t by itself. So I need to do the same thing to both sides to get t by itself. So I'm going to square root both sides. And I end up with t equals 3.03 seconds. That's how long it's in the air for, 3.03 seconds. Now that I've got that piece of information, I can now go one step further. How fast was the object going when it reached the ground? So I'm solving for my final velocity. That's what I'm solving for. I have the same set of givens I did before, except now I'm adding in that I know that it's in the air for t equals 3.03 seconds. So I'm choosing to use this equation. There are other ways to solve for it. This one's the quickest. I'm solving for v. A is still negative 9.8 meters per second squared. Same givens as the previous page. The time is now 3.03 seconds. That's one thing I know now that I didn't know before. And my initial velocity is still 0. All I have to do is multiply together, and I get negative 29.7 meters per second. This is the velocity when the object reaches the ground. It's negative because the object is traveling downwards when it reaches the ground. That is a freefall problem.